Everyone, this is the second video of my YouTube channel on statistics. Today I'm going a little bit more in depth into descriptive statistics for numerical variables. The previous video we've seen how to calculate mean, mode, and standard deviation and so on for a numerical variable. In this video, we are going to talk mostly about the distribution of the data and how to recognize normal variable and so on. First of all, we again load the data. We already seen this data set from previous videos. As the data set is iris with the data from different type of flowers. We can also look at the data. We see we have 5 variables: sepal length, width, petal length, width, and species. And in total, this data set has 150 observations. So first of all, we will use 2 packages which are not built in R, and are basically are necessary for this type of analysis which I'm running in this video. These packages are the package Psych, which is very useful, and I use it quite frequently, and also the package Desk Tools. Now, for those who are not familiar with R, the way to install packages in R is extremely easy. Basically, you simply type install packages, and then in brackets you put the name of the package that you want to install. And this is what we do at the moment, and it's installing the package just now. You can see it's running and uploaded, and now we have the package installed. And then to call it in function, you simply type library and the name of the package, and there you go. You got your package. So this package has this command, which is very useful. Is called describe. Of course, it describes the variable. That's simple as it is. So if we take our iris $ sepal length, so we are going to describe the variable called sepal length inside the dataset called iris, we obtain a large number of information. We've gone through previously how to calculate mean, standard deviation, and so on. Here we have much more information. First of all, the location of the variables in the dataset, it's the first variables, the number of valid observation, and we have 150 observation, the mean, of course, the standard deviation, the median. This is the trim mean. By default, the distribution is trimmed by 0.1. And then we had the MAD, which is the median absolute deviation, the minimum and maximum value inside this distribution, the range between minimum and maximum, and then 2 important variables, 2 important factors here, which are skew and kurtosis. Now, when we analyze those numerical variables, the first important factor to consider is that skewness and kurtosis are important parameters to understand how the overall distribution is actually shaped. The normal distribution, as we know it, is also called the Gaussian distribution, is a probability distribution that is symmetric between about the mean, basically, so that the occurrence on the data are equally distributed on both sides of the mean. And if we want to see a normal distribution, here I simply produce a simple normal distribution, and I plot it to show you what is looking like. So if we see this as a normal distribution, we can clearly see that there is the mean is 10 in this case, and the values are equally distributed around this mean. And of course, in this case, you'll have a very symmetric curve. And but this is not always the case. Sometimes you have a certain distribution which are not equally distributed across the range, and these are called skewed distribution. In this case, we have a positively skewed distribution. Now this it's a plot of a positively skewed distribution. Again, you can see that vast majority of the observation are between 0 and 15, but you have quite a large number of observation even after 15, and the curve is basically skewed on the right side, on the left side of your distribution. In this case, it's positively skewed. And this is important to understand if actually we are talking of a normal or an abnormally a normal distributed or a skewed distributed numerical variable. With the describe function, we can obtain those information, as well as another parameter which describe produces the kurtosis. Now, if we go back to the describe function, in this case, I describe function for my normal distribution, which I've created here. We can see that I created a variable with 10,000 observation. The mean is 997, standard deviation is 2, median 998, trimmed mean is 997. And if we go to the skew, this is 002. This is a very small skew, and that tells you that basically the curve is most likely to be normal. At the same time, the kurtosis is also a statistical measure of this shape. Basically, when the skewness differentiates extreme values on one side or the other tail of the curve, kurtosis measure extreme values in either tail. So the distribution with large kurtosis would have of course, a skewed distribution, while those with a small kurtosis would have not. In this case, the kurtosis is very small, minus 0.002. If we run describe for the other variable that I produce, so the one that is non-normally distributed but is positively skewed, not surprisingly, the skew here is positive, as we know, and is 0.62, and the kurtosis is 0.5, so it's much larger than the previous one. Another important point that we can see in descriptive statistics is not only related to the main measure of variance and central tendency, but also, as you can clearly see, their distribution. It is essential to understand this difference when you are going to run inferential statistics, even in the sense of using the correct statistical test when analyzing data. Now, before concluding this video, I wanted to show you this other important package which I found very, very useful. It's called Desk Tools, and we launch it, of course, by typing library desk tool. And with this command desk, you can see many important variables and important factors describing your distribution. So by typing this, let's start with the outcome that we would have. We again have information about the length of your variables, the number of valid observation, the number of missing observation with their relative percentage, and then the number of unique values, as well as we have a mean and mean confidence interval. And we'll have those which are basically quantiles. Now, the quantiles are the cut points in which you divide your distribution, probability distribution, into with equal probability. So this is, we call them in this case, that would be centiles. So you will have 100 centiles, and this is the 5th centiles, this is the 95th centiles, and it will tell you where each centile stands across your distribution. We will also have information about the range, the standard deviation. I'm not going into those which are a little bit more important more complex factors. And then we have skewness and kurtosis again. We have a positive skew with a negative kurtosis, quite large, I would say minus 0.6. So if we do the same, this desk command will also provide you with a plot. A very nice plot, I must admit. This plot will basically describe you again your distribution with an histogram with a frequency distribution, and will also provide you the same sort of image from an histogram plot from the top. And again, is it easily telling you where your mean and standard deviation, so your mean and median may stand, how roughly normally this variable is distributed, and so on. If we test the same package with a normally distributed variable which I have created, you will see something like this. And clearly, this is a normally distributed variable with the obvious bell shape curve. If we run the other one, which is non-normal but positively skewed, not surprisingly, we have a very similar description. So this command, it's very helpful and quickly provides you with the major information of the distribution of a numerical variable that you are interested in. Another important concept to consider, that at times you want to have the information of a specific group inside your data set, and you want to see how the same variables is distributed across three different type of for your grouping variables. So in Iris, I use this as a grouping variable. I use the species, and my variable of interest is still Iris sepal length. And this time, again from the library PSIC, we call describe by, and if we run this, we basically have the same descriptive statistics, but divided by group. In this case, we have three groups, of course, setosa, versicolor, and virginica, and with each of them have 50 sample each, and all of them, they provide you the mean, the standard deviation, and all the rest. We can already see clearly that virginica has a sepal length which is on average longer than versicolor, and even more for setosa. This is not enough to conclude that there's statistical significance or not, but it is probably already good enough for us to understand that we are facing some important difference, maybe. So next time we will go through the categorical variables and how to describe them, and then we will slowly start some statistical analysis of those variables. Thank you.